Hi guys, today we're going to talk about coordinate proofs, which basically is using the knowledge we have about the coordinate plane to make determinations about geometrical figures, specifically using slopes and distance formulas, things like that. So there's two basic things that we want to do. We want to use distances to show that figures have congruent sides, right? And we also want to use slopes to show that the sides are parallel or perpendicular. Of course, if the slopes of two line segments are equal, then we know that the lines are parallel. And if the slopes are opposite reciprocal, then we know that the two lines are perpendicular. And so those are the two basic, most common things we're going to deal with. Sometimes we'll also use midpoint to prove things as well. But let's just go ahead and look at a specific example and see how this works out. Today in class, of course, we talked about some of the properties, the definition of a parallelogram, and some other figures. So if I want to show that this figure down here, this quadrilateral, is a parallelogram, I've got two ways to do it. One is to show that opposite sides are parallel. That's enough information to prove that something's a parallelogram. And so let's try that first. So to show parallel, I need to calculate the slope of each side. So the slope of, let's just start with MJ. The slope of MJ is going to be change in y over change in x, of course. That's how we're going to find slope always. So the slope of y is 1, 2, 3, it's up 4 and over 3. That's the change in y over the change in x. The slope, I want to show that that's the same as LK, hopefully. Right? And that would be here, I would have my y coordinate minus the y1 minus y2, which is -1, over x1 minus x2, which again, that's the minus and minus becomes a plus, so I get 4/3. So that checks out. Those two opposite sides are in fact parallel. And then I can do the same over here. The slope of JK is going to be, let's see, 3 minus 5 is a change in y, and 4 minus -3 is a change in x, so I get -2/7. And if I do the same with ML, I get, let's see what we got here, -1 minus 1 over 1 minus -6, which does give me 2/7. So I would wrap this up by making some sort of statement like JK is parallel to ML and JM is parallel to KL. Therefore, this figure is a parallelogram, and I've set out to do what I tried to. Let's look at another way we could have done this. Okay, so of course I could also prove that something's a parallelogram by showing that their opposite sides are congruent. So the length of JK, for instance, is the square root of the change in x, which was 7 squared, plus the change in y is 2 squared, which is the square root of 53. If I try the same thing with ML, we already found the slopes, right? So the change in x was 7, and the change in y was 2, and so I get square root of 53. Those are the same lengths. And then, of course, for the other two, JM, we have the square root. The change in x was 3, and the change in y was 4, so I get square root of 25, which is 5. And KL is 3 squared plus 4 squared is also 5. Again, the change in x and change in y is all we're doing to find the distance formula. So I've shown now, I'd have to make some sort of statement now. I would say MJ is congruent to LK and LM is congruent to KJ. Therefore, opposite sides are congruent, and this figure is a parallelogram. Okay, the second example here is about proving that a triangle is isosceles, which again, we need to know what that means, and what it means to be an isosceles triangle is that it has exactly two congruent sides. So I'm going to need to find the lengths here. It has nothing to do with parallel or perpendicular, so I need only distances. So let's do this thing one at a time. The distance from A to B, let's see, we have the change in x, which would be like 0 minus -4 squared, plus the change in y, which is 2 minus 6 squared. So that gives me 4 squared plus 4 squared is the square root of 32. We don't really need to simplify because I'm just trying to show that they're the same. BC, the change in x would be 0 minus -4 squared again, and 2 minus -2 is a change in y, so I get 4 and 4 again, and that also is the square root of 32. So I've got 2. I should still find the length of AC, because if it's the same as well, it would be equilateral. Lucky for me, the change in x is 0, so I just have to find the difference in the y's, which is 8, and 8 clearly is not equal to square root of 32. So now I can say AB is congruent to BC. Therefore, triangle ABC is, in fact, isosceles. Let's take a look at one more example. Okay, I want to show that this figure, this quadrilateral, is a rectangle, which requires two things. I need opposite sides to be parallel. Whoa, I don't know what's happened there, sorry. I need opposite sides to be parallel. I also need to show that adjacent sides are perpendicular. I need to show that there are right angles. Okay. I could also do this with showing that opposite sides are congruent, but the difference between the parallelogram proofs is this part. I need to show right angles somehow. And since I'm going to have to find slopes to do that anyways, I may as well use slopes to show that opposite sides are parallel. So QR, let's find that first. The slope of QR, change in y is 7 minus 4. Is that right? Change in x would be like -6 minus 6. So I'm getting 3 over -12. This is -1/4. The slope of ST is equal to -1 minus -4, which is going to give me 3, I hope we see, over x is -7 minus 5, so that's going to be -12, and I get -1/4, so I'm halfway home. To keep going, now we can find slope of QT, which is equal to 7 minus -1 over -5 minus -7, and that gives me 8 over 2, which is 4, and the slope of RS is 4 minus -4 over what is that, 7 minus 5, which is 8 over 2, which is 4. So I have all these slopes here, and we got exactly what we were hoping for, so now we can make some sort of statement about it. We know the slopes of opposite sides are congruent. Okay, we found that the slopes of adjacent sides are opposite reciprocals. Okay, so at this point we can say, in fact, that and you could actually use the exact letters, right? Like I can say that TS, for example, is parallel to QR, right? If this would scroll, and I can say that TS is perpendicular to TQ, and TS is perpendicular to RS, and we could say all these things, but the bottom line is we've shown, and I could keep going, but I think you get the idea. The point is I've shown now that there are 4 right angles in this figure and that it is a parallelogram, and so I can conclude that QRST is a rectangle, and we're done. So the idea is we're just using distance formula and slopes to prove things about these figures simply just through our calculations, and we're going to practice this a lot more in class. I hope that makes sense. Thanks.